This is for Specialist Maths. It comes out of the 2020 Chapter 7, Techniques of Integration topic test, and it's question number 4, which is the integration by recognition question. It's integration by recognition, and I know that because I'm told to take the derivative of something and then hence use that derivative to come up with the evaluation of this. Okay, so I need to take this derivative first. So d dx of 2x inverse sine of x is going to be a product rule question where u equals 2x and v equals the inverse sine of x. So u dash will be 2 and v dash will be 1 on top of the square root of 1 minus x squared. So I'm going to have 2x times on top of the square root of 1 minus x squared plus 2 inverse sine of x is going to be what the derivative will equal, which will be 2x on top of the square root of 1 minus x squared plus 2 inverse sine of x. So there is my answer to part A. Part B then says, hence evaluate this. Okay, so now I'm going to integrate both sides of this expression with respect to x. The integral of the derivative of this is 2x inverse sine of x will equal the integral of 2x on top of the square root of 1 minus x squared dx plus 2 integral of inverse sine of x dx. Now this is an integration by recognition because the game I need to play is I need to recognize this in this expression and I can see it there. So there it is there. So I'm going to use algebra to isolate this all by itself. So if I put this by itself, I will have the integral of the sine of x dx, and I'll call it 2. And that's going to equal 2x, the inverse sine of x minus the integral of 2x, top of the square root of 1 minus x squared dx. So the sine inverse of x dx integral will equal, I move the half over, so that cancels and that cancels to leave x, inverse sine of x minus integral of x on top of the square root of 1 minus x squared dx. So that's just doing some algebra to isolate this all by itself by taking this to the left, bringing this over so the integral is a subtraction, and then dividing by 2. Because that's 0 to 1, 0 to 1. Now, I would like to treat this as a u. The derivative of the bottom is minus 2x dx. So then that's going to become a plus, and that's going to become a half. So I've got plus a half, the integral from 0 to 1, of 1 minus x squared to the negative a half times minus 2x dx. And that's the derivative of the inside. It's going to be plus a half of 1 minus x squared to the half divided by a half, and those halves will cancel. So I've got x inverse sine of x plus x 1 minus x squared to the half, all from 0 to 1. Subbing in the 1, I've got 1 times the inverse sine of 1 plus 1 minus 1 squared to the half minus 0 minus 1 to the half. Inverse sine of a half is going to be, of 1 is going to be pi on 2. That gives me pi on 2, that's 0 minus 1. So that's what the integral from 0 to 1 of, I've forgotten what it was again, inverse sine of x dx, and just to double check that, and the calculator agrees that pi on 2 minus 1 is going to be